Hey everyone, I hope you had a great weekend. We are on our last lesson of the year. I can't believe it. Um, so we are covering probability of simple events. Okay, and it's the last thing we're going to learn before we take our end of unit test next week. So, how do I find the probability of a simple event? So we are finding probability, and there's some vocabulary you need to know before we move on with finding probability. So I know you all have heard of an experiment. In math, we're going to say an experiment is an investigation or a procedure with varying results. So let's go ahead and write that down. Investigation or procedure with varying results. Okay, so an example for an experiment having to do with probability would be like flipping a coin. So I'm going to write down flipping a coin for my example. Okay, so the outcome is a possible result from the experiment. So let's go ahead and write what an outcome is. Come on. A possible result from the experiment. Okay, so if the experiment was flipping a coin, then the outcome would have to be heads or tails, right? So a possible outcome, we'll say heads. Okay, what is sample space? So sample space is the set of all possible outcomes. So what did I say the outcomes were for flipping a coin? That's right. I said it was heads or tails. So that is my sample space. So if I'm writing a set, I'm going to put it in braces. Sorry, I don't know what's happening right now with my pen. Okay, so braces look like this, and my outcomes were heads and tails. So those are my only two choices, so that's my possible outcomes. Okay, so let's apply it. The first example says, give a sample space and number of outcomes for each experiment. So a state that begins with the letter O is chosen. Okay, so states that begin with the letter O. Okay, that is Ohio, Oklahoma, and Oregon, I think. Um, let's go ahead and check. So, states that begin with O. Ohio, Oklahoma, Oregon. Okay, I got them. So that's three outcomes. Okay, so a day of the week is chosen. Well, let's go ahead and write down the days of the week. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. Okay, so that number of outcomes is 7. So, probability is a measure of the chance or a specific event occurring. Okay, and it's noted as the probability of the event. So, like P and in parentheses E. And it is expressed as a ratio of favorable outcomes to the total number of outcomes. The ratio can be written as a fraction, decimal, or percent. And then finally, the sum of all probabilities in a sample space is equal to 1. Okay, so we are ready to start probability. All right. So we said probability is a measure of a chance of a specific event occurring, written as a ratio, like a fraction, right? And we're going to write the favorable outcomes to the total outcomes. Favorable over total. So we're looking at this spinner in number 3. And it says the spinner below is used in a game. If it is spun once, find each probability. Okay, so A says find the probability of spinning 9. So we look at our spinner and we mark how many spaces say 9. Okay, so I'm going to mark it. You may or may not choose to mark yours. It actually doesn't matter as long as you can erase. So the probability of 9 is 1 out of how many spaces total? 16. So the reason why it's a 1 in the numerator is because there's only one 9 on this whole entire spinner, and there's 16 spaces. Okay, so now let's write the probability of spinning at least 12. Oh, look, I didn't read the instructions. The instructions say give the probability as a fraction in simplest form, a decimal, and a percent. So I wrote it as a fraction, thankfully in simplest form. Now, what is 1/16 as a decimal? Well, we're going to do 1 divided by 16. 1 divided by 16 gives me the decimal of 0.0625. Zero point. Oh no. I'm sorry, guys. My pen is really just messing with me today. 0.0625. And as a percent, do you guys remember what to do? You move your decimal to the right 2 places. Okay, so as a percent, hold on, my pen, come on. My decimal moves to here. So that is 6.25%. Okay, now we're ready to move on to question B. So I'll change colors. The probability of spinning at least 12. So let's just go ahead and make this super clear. If I have at least $12, I have $12 or more. So the probability of spinning at least 12 is 12 or more. So I'm going to mark every space that has a 12 or higher. So here I'm marking 12, 13, 14, 15, and 16. So how many did I mark? I marked 5. out of how many spaces in total? 16. Is that a fraction in simplest form? Yes, I don't need to reduce it. Okay, so what is 5/16 as a decimal? So I'm going to get my calculator and I'm going to do 5 divided by 16, 0.3125. So that is 0.3125. And as a percent, we'll move our decimal place 2 places to the right. That's 31.25%. Okay. So C says, find the probability of spinning a perfect square. Well, you guys learned your perfect squares this year, right? 1 through 20. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. Okay, we could keep going, right? 5 squared is 25, but 25 isn't on the board. So that is 4/16. 4/16, which reduces to a quarter. Okay, and to change 1/4 into a decimal, do you guys already know this one? 1/4, 1 divided by 4, 0.25. And making that a percent, move your decimal 2 places to the right. That's 25%. So this is pretty easy. Okay, so let's find the probability of spinning a number that's not shaded. So we're going to mark all the spaces that are not shaded. How many did I mark? 7. And how many spaces total? 16. Okay, 7/16 as a decimal. 7 divided by 16 is 0.4375. And as a percent, 43.75%. Okay, so hopefully you guys think this is easy, right? You can use your calculator because you're at home. Let's do part E. Probability of spinning a 2 or an 11. So how many 2s are on the board? Just 1. How many 11s? Just 1. So that's 2 spaces out of 16, which reduces to 1/8. 1/8 as a decimal. 1 divided by 8 is 0.125. And 0.125 as a percent is, oh, hold on. I'm losing my pen here. 12.5%. All right. And part F, multiples of 5. So multiples of 5 would be like 5, 10, 15, 20, 25, 30. So we're marking any multiple of 5. 5, 10, 15. All right, and that's the highest multiple of 5 that we have. So that's 3/16. As a decimal, 3 divided by 16, 0.1875. And then finally, as a percent, 18.75%. Okay, so that was actually more work than I thought it was going to be, only because we had to convert our fractions to decimals and to percents. but it's good practice anyway because I'm fairly certain that in your IXL assignment for the week, you're going to have to be answering your probabilities in all forms, fractions, decimals, and percents. Okay, so let's move on. I will scroll this way slightly, not so much. Okay, I'm going to let you guys do number 4. And let's go ahead and do number 5. A letter from the word probability is chosen at random. Find each probability. Okay, so first thing, let's go ahead and count how many letters are in the word probability. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so that's 11 letters. So that's our total, right? So let's find the probability of choosing a B. So let's say we wrote the letters for the word probability on cards. We would need 11 cards. We'd put a P on the first one, an R on the second one, an O on the third one. And we put all the cards in a bag. And we pulled out a card. What would the probability be of choosing the letter B? Okay, well, there's only 2 B's in the word probability, right? So right here and here. So that's 2 B's out of 11 letters or 11 cards, right? So 2 11ths as a decimal is 2 divided by 11, which is 0.18 repeating. So 0.18 repeating. And as a decimal or as a percent, okay, we're going to make it 18.18 repeating percent. Okay, so what's the probability of choosing a vowel? Well, how many vowels do we have here? Charlie. Sorry, guys, that's my puppy. He's tired. Okay, so we have an O, an A, and 2 I's. And a Y. Does it include the Y? We'll just say no for now. It says sometimes Y. Okay, so that's 4 vowels out of 11 letters. And 4 11ths, 4 divided by 11 is 0.36 repeating. Okay, and 0.36 repeating as a percent is 36.36 repeating percent. All right. What's the probability of choosing a Y? Okay, well, how many Y's are in the word probability? There's only one. So that's 1 11th and 1 11th as a decimal is 0.09 repeating. And changing 0.09 to a repeating to a percent is 9.09 repeating percent. Okay, so don't get too hung up on the math portion here. I don't think you'll have repeating decimals in IXL. And if you guys get stuck, you can always send me a picture of the problem that you get stuck on and I'll help you work it out. Okay, let's do number 7 together. So you guys can do number 6 on your own. Number 6, you're going to have to add 5, 6, 8, 3, and 2 to figure out the total number of colored pencils, right? Okay, and so I think you can figure it out. If not, let me know, and I can make another video for you. So number 7 I chose because I know a lot of people don't know decks of cards. But you guys are learning at home, so of course the internet is at your disposal. If you're unsure, just look it up. It says if a card is chosen at random from a standard deck of cards, find each probability. So there are 4 suits, right? And each suit has 1 through 10, Jack, Queen, King, and Ace. So if there's 4 suits, there's going to be 4 queens. So that would be 4. Hold on. That would be, 4 out of 52 cards, which reduces to 1 out of 13. And 1/13 as a decimal. 1 divided by 13. Okay, we're going to round that number to 0.0769. Okay, and writing this as a percent is 7.69%. Okay, what's the probability of choosing a red 3? Okay, well, in a standard deck of cards, half the cards are red and half the cards are black, right? So the red ones, there's 2 red 3s out of 52 cards in total. And I need to reduce this, right? That's 1/26. And 1/26 as a decimal, 1 divided by 26 is another very large number, which we're going to round to 0.0385. And 0.0385 as a percentage is 3.85%. Okay, what's the probability of picking a spade? Well, spades are suits, right? So they have 13 spades in a standard deck of cards out of 52 cards, which reduces to a quarter. And 1/4 as a decimal is 0.25. That was just like number 3, part C, which is 25%. Okay, so it is not so bad. What happens if you see this symbol? The probability of a complement of an event. So the complement of an event is a probability of the event not occurring. So let me change my color here. The probability of an event not occurring. Since the sum of all probabilities in a sample space is 1, okay, we got that from our notes over here. The probability of an event not occurring is 1 minus the probability of the event. Okay, so let's do a couple together. Number 8 says, if the probability that it will rain tomorrow is 3/8, what is the probability that it will not rain? Well, we're going to do 1 minus 3/8. Okay, well, if we're doing 1 minus 3/8, we're going to do 8/8 minus 3/8. So let me change this 1 to be 8/8 minus 3/8 is 5/8. So the probability that it will not rain is 5/8. Okay, and 5/8 as a decimal, 5 divided by 8 is 0.625. So that is 0.625, which is 62.5% chance that it will not rain tomorrow. Okay, I'll let you guys do number 9, and I'll do number 10. So a number from 1 through 20 is chosen at random. What is the probability that it's not a prime number? Okay, so prime numbers. Let's go ahead and consult the internet, because I'm not sure if 1 counts. Prime numbers 1 through 20. So that's 2, 3, 5, 7, 11, 13, 17, and 19. So that's these numbers. So how many numbers is that? 1, 2, 3, 4, 5, 6, 7, 8. 8 numbers. So they don't include 1 as a prime number. Okay, so 8 numbers out of 20 are prime. What's the probability that it's not prime? So we're going to do 1 minus 8/20ths. And my pen is still messing up, sorry guys. So 1 minus 8/20ths is the same thing as 20/20ths. Oh, come on, pen. Maybe if I scroll down it won't be so bad. We're almost done here. So that's 20/20ths minus 8/20ths is 12/20ths. So 12/20ths reduces to 6/10ths, which reduces to 3/5. And 3/5 as a decimal, 3 divided by 5 is 0.6. 0.6. So 0.6 as a percent, 0.6 as a percent is 60%. Okay. I am going to do number 11 with you just because it's the hardest one. So you guys are going to do number 9, number 6, and number 4 on your own and a summary before turning in your notes. Okay, so let's do number 11. 11 says a state is chosen at random. What is the probability that it does not begin with the letter M? Okay, so we're gonna check and see how many states begin with the letter M. So states that begin with M. 8 of the states which make up the United States have names that start with the letter M. Maryland, Michigan, Montana, Missouri, Massachusetts, Mississippi, Minnesota, and Maine. Okay, but the key word here is 8. And so we have 8 states out of 50 start with M. How many do not start with M? We're going to do 1 minus 8/50ths, or 50/50ths, right? So 50/50ths minus 8/50ths. Oh, come on. And 50 minus 8 is 42/50ths, which can be reduced to 21/25ths. Just divide it in half. So 21 out of 25 as a decimal. It's 0.84, which is 84%. So I want you guys to notice I use Google a lot if I'm unsure. If you're stuck make sure that you're using all of your resources to help you. Okay, so we're done with our notes. You have an IXL assignment and a maze to complete this week. If you get stuck on anything, please do not hesitate to email. Send a picture. I'm happy to make you your own video. Okay? I hope you all have a great week. I miss you. Bye.